Okay, we're in section 38. This is the parabola section, the section on parabolas. So we went through the lecture portion. Hopefully you paid attention and you're starting to make sense of what a parabola is. All right. The problem that we're going to be dealing with is a parabola of the form y equals ax squared plus bx plus c. Are there other forms? Yes. Let's not worry about that. Let's worry about what we just said lecture. So basically what we do is we have, x-intercepts, y-intercept. If they're easy to get, fine. If not, let's not bother with it. The other thing is going to be a vertex. Generally speaking, fairly easy to get. It does require some thinking on your part. And we did discuss that during lecture. Also an axis of symmetry that goes through that. Now, when I say an axis of symmetry, what I notice is that it's a folding symmetry. It's a line of symmetry where the parabola folds over that line. All right, so what we're going to do now is we're going to go to examples. The examples we're going to do is try to illustrate what was discussed in the lecture portion. Hopefully, what was discussed in the lecture portion will make more sense as we start to do examples. All right, so I'm going to switch to the whiteboard and give you a moment to do so. And we'll do one problem at a time. And let me just go backwards. We're going to go backwards to example number 1. And let me push this over here. And I'm looking at example number 1. Now, certainly if I'm doing the problem, it may look a little different than what you would attempt to do the problem. But the bottom line is they want me to find the coordinates of the vertex. Well, I realize that's something new to me. So what I would do instead is I would try to factor the problem. Right now, someone says, what do you mean factor it? Well, I'd look to see if I can factor it with my fingers. And if I do that, that would be x and x. 3 and 1, it's the only choice. And let's see what you get there. I guess you get -3 plus 1, but whatever I say it is. I'm not going to say it is until I try. X times x, x squared. -3x plus 1x minus 2x works beautifully. So I'm going to, put a table of values down now. I'll plot these things out later. I'll worry about their questions later right now, but I'm looking for easy things to do. Now, one thing I'm going to do is I'm going to set the x to be 0. And if you set x to be 0, you get a y-intercept. What is it? Well, if you plug in 0 over here, what do you get? 0, 0, you get -3. Fairly simple. The next thing I do is I'm going to set y to be 0. Well, if y is equal to 0, it means these factors equal to 0. When would that occur? At 3 and at -1. All right, so put that down. So at 3 and at -1. So what I'm going to do is I'm kind of ready to plot this out for you. And someone says, what do you mean you're ready to plot that out? I'm going to go over here and I'm going to plot those points down for you. All right. Now, granted, if you can't remember, I want to point out, I'm going to plot the x-intercepts first. So 3, 0. Let me blow this up. And -1, 0. Again, remember, if you can't remember, what you're going to do is look back over there and 0, -3. I'll put this over here for you. And by the way, when I'm looking at this thing, I am definitely looking for the symmetry between the x-intercepts. And what's nice about having graph paper, it should be easy to determine that there's a line of symmetry. What do you mean by that? There's a line that goes through here where there's a folding symmetry. Now, what I mean by that, there's 2 units here, 2 units here. What is that line? Let's put it in. That line would be right here. Now, I'm putting it as a dashed line. And I'm going to say that's my axis of symmetry. I'll write that down in a second for you. All right, so let's write the points I have down. So I have a y-intercept. I'll write that over there for you. And I realize some students say, I don't know if they asked for that. Well, it's so easy to get. Why not just answer it? It's 0, -3. We have 2 x-intercepts. These are nice integer numbers. -1, 0. We have another x-intercept, which would be 3, 0. We also have what's known as an axis of symmetry. I abbreviate that AOS. What's that going to be? A vertical line, x equals 1. But I don't have my vertex. The only thing I know about the vertex, it has to be on the axis of symmetry. And what does that mean? The point, x must be 1. Here comes the trouble. Someone says, I wonder where that is. Well, I got to go back to the original problem. And I got to plug 1 in. Let's do that. y equals 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is going to be minus 4. So now I have it. Go back over here, and I'll put that down for you now. So minus 4. I'm going to plot that point for you right here. Now, someone's going to say, could you finish it out? I'll be honest with you, you certainly could. Before I do that, though, I want to claim there's a point over here as well. And why is that? There's a folding symmetry, right? Someone says, do I need to put that point in? No, but it's nice to know about symmetry. I'm going to draw my parabola, and it's a nice looking curve. Click this over here. And I got my parabola in there. All right. Let's go to the question itself and let's see if I've answered the question. All right. I know it's difficult, but you want to go back and read the question now. You might say I've done too much work already. Let's take a look at it. Find the coordinates of the vertex. Have I done that? Yes, I said it's 1 minus 4. I got that part. All right. The equation of axis of symmetry. Have I done that? Yep. I said it's x equals 1. Yep. I got that covered. It says, over here, anything else? No, nothing else except graph it. Did I graph it? Of course I did. It's right over here. We're done. Right? We did a good job at that. All right, let me repeat this for some students. Sometimes this goes way too fast for them. It really does. They're confused. So what I want to claim over, if you're really totally confused, come back later in the week and rewatch the lecture. Just pay attention. Or you may decide to watch these little spot videos on the side, and you'll see me do this over here. It's certainly going to look different in a spot video because this is a lecture period. And what does that mean? I'm doing this during lecture. These were done off lecture. Let me go to problem number 2. And I think it's on the same page. Whoops, sorry about that. It's over here. And I'm going to do the same thing. And someone says, what do you mean doing the same thing? Same thing I did before. What did I do before? I try to factor. So let me see if I can do that. It looks tough, but let me try it. I personally would factor out minus 1 in this one. That's just me, by the way. You don't have to do that. Well, I did it again. That would give me x squared minus 2x plus 3. Well, you know what? No matter what I do here, I'm not going to get that to factor. Right? No matter what I do, I'm not going to get that to factor. When I say that, using finger numbers. For example, if I use finger numbers over here, I get minus 1, x and x. 3 is the only choice I have over there. And there's nothing I can do to get plus 3 and a minus 2. There's nothing I can do to do that using finger numbers. So I'm going to say factoring really was unproductive. So I'm going to erase that. Unproductive. But you know what? I think I can get a really simple point here. And the point I want to get is I want to get the y-intercept. It's super simple. I would always go for it. What's the y-intercept? You said x to be 0. Now, if you said x to 0, what do you get? You get minus 3. That was super simple. Now, I want to get the vertex, though. To do that, what I'm going to do is I'm really going to say the axis of symmetry is going to be x equals minus b over twice the a. Well, let me identify that. The a is minus 1 and the b is 2. Let me write this down. The opposite of the b is minus 2 and twice the a is minus 2. What does this give me? 1. So I know the axis of symmetry, I'll write this down for you, is x equals 1. I also know the vertex must be on that line, which means x equals 1. How do I do that? I plug it in. So what's the y going to equal to? Y will equal minus 1 squared, yep, I'm pressing as a variable, plus 2 times 1 minus 3. Let's do the arithmetic. Minus 1 plus 2 minus 3. And what does that give you? Let's see, that would give you minus 1 plus 2 is 1, minus 2. I'm going to graph it, right? We'll get to that questions later. So what do I know? I know the y-intercept is 0 minus 3. What else do I know? Axis of symmetry is x equals 1. Let me put that down for you. We'll go to the key later, okay? What else do I know? I know the vertex is at 1 minus 2. Well, I'm kind of looking at it, and I got a real good idea that there's a folding symmetry, but that lacks a symmetry. So I say there's got to be another point over here. So how'd you know that? I'm looking at this point here, and it's got to be reflected through that line over there. What's the parabola look like? Well, I really have very little choice in this. It looks like this over here. We're just drawing a rough picture. I do want to claim over here that this coefficient here is negative, is on the square term, which means it opens down. All right, let's see if we've done a good job. And by that, what I mean is, did we get the correct answers? Sorry about that. Let's take a look. Did I get the vertex? I didn't write it down, no. I have to write this over here. This is the vertex, and sorry about that. I spoke it, but I didn't write it down. I got that right. Axis of symmetry, I got that right. And this is the graph. Let's go to the next page, number 3. And let's take a look. And again, I think you probably know what I'm going to do. I'm not even going to read it. I'm just going to go through it. Right? So this is, why do you go through this? I want to make sure I can understand what's been presented to me. And I think you probably know I'm going to try to factor that guy. Even if it doesn't work, I'll try to factor it. 2 times x squared, this was known as a GCF, minus 8x plus, let's see, 15, 17. Well, I'll be honest with you, that's a little unproductive because I really can't go to factor that any further. Like, for example, I try to factor, what would I get? 2, x and x, 17 and 1. And there's no way I'm going to get 8 out of that. So it wasn't a big waste of time, but for the most part, it didn't lead anywhere. Right? I haven't read the question yet. Let's keep going through it. What I want to do over here is I want to get the y-intercept. I believe it's easy. What do? Set x to be 0. What do you get? 0, 34. How did I do this so quickly? I plugged it in. 0, 0, 34. So I'm getting that. I'm going to do the axis symmetry. And what's that going to be? X equals minus b over twice a. Let's see if we can do that. A is 2, and b is minus 16. Well, let's write this down. Well, minus 16 is 16, and twice a is 4. This would be 4. So my axis symmetry, and again, I'm not saying they asked for it. I'm just saying it's useful in general. And from this, I can get a vertex. What's the vertex going to be? Well, let's take a look. I know the x is 4. It has to go through the axis symmetry. We'll graph it later. And I want to figure out what the y is. And it might be difficult. Who knows? What do you get? Y equals 2 times 4 squared minus 16 times 4 plus 34. What do I get here? Well, 4 squared is 16. 2 times 16 is 32. Minus 16 times 4 is 64. Plus 34. I'm going to keep doing that. Let's see, that would be minus 32 plus 34 would equal 2. I got the vertex. Well, I'm going to put this stuff down. Now, one thing I don't want to put down is I don't want to do this because it's too much counting for me. So what I'm going to do is I'm going to put the vertex down and the axis symmetry. I'll put these 2 things down. All right, look at my picture. So again, x is 4. It's nice to have graph paper. X is 4, and the vertex is 4 too, right? Let's put this over here. That's the vertex. Now, by the way, I only got 1 point and a line of symmetry. And what do I know about this thing? I know the graph opens upwards, right? So I'm going to I'm going to draw that in. And I'm not saying I'm doing a great job, but there's a point to it. The graph looks like this over here, somewhat like this. All right. It's a parabola opens upward. Someone says that was not their question. And I realized that wasn't their question. What was their question? What's the domain and range? So I'm looking at this thing over here, and the domain couldn't be any easier. Why is that? I'm seeing no even root taking, and I'm seeing no division. So the domain must be all the real numbers. Range is more difficult. Range, for most students, you're required to look at a picture. And I want to emphasize what I'm looking at. The range is what's being covered here. Well, I want to be honest with you, it starts here, and then it goes off in that direction. So where's it starting in this direction? Well, it's starting at the number 2. Does it touch 2? Yes. That's where the vertex is. And then it goes off to infinity. Let's look at our key. What does it say? Domain and range. Okay, let's keep going. Let's go to number 4. And where is number 4? I guess on next page. Yep, number 4. Well, I think you probably know what I'm going to do. I'm going to factor it if I can. And what do you get there? X and X. I'm going to say 3 and 2. I can immediately write down some things I like X intercepts. Where they're going to be 3, 0, 2, 0. And I can write a y-intercept down too. Really simple, isn't it? What's the y-intercept going to be? Well, it's when x is 0, you'd get 6, right? So I'm going to graph that. And, when I do the graphing, it might be tough, but let's see if we can do it. Again, if you can't remember, go back. 3, 0, and 2, 0, right? Boy, that's a tough one, isn't it? And what else am I going to put down? The y-intercept 0, 6, right? I count 1, 2, 3, 4, 5, 6. By the way, I really think I could put the axis of symmetry in. And what I mean by that, if I did that, it's tough to do that though, isn't it? And I bet you could write down the axis of symmetry just looking at this graph now. We'll do the formula too. X equals, what would that be? It's dead center between 2 and 3, right? That would be 5 halves, wouldn't it? What's the vertex going to be? Well, it's going to be when X is 5 halves. And again, I'm just thinking now. And this is number, I'll write this down. So Y equals, and again, I'm not saying they ask the question. I'm saying I want to make sure I can review this. And what do you get there? Y equals 25 quarters minus 25 halves plus 6. Yeah, it's a lot of work, isn't it? Common denominator of 4. 25 minus 50 plus 24, which would be 1/4. All right, go back over here. So my vertex, write that down for you. Is going to be what? 5 halves, comma 1/4. Now, granted, it might be tough to plot that, but 1/4 is about here. Can I draw my parabola in? I think so. It looks sort of like this over here. And it goes up, goes through that point there. And I think you got a good idea that you can continue graphing that out if you want. Someone says, I don't even think that was their question, but I still want to go through it with you, right? I still want to go through this thing. So I want to write down domain of it. That's simple, minus infinity to infinity. I want to write the range of it down. And what's the lowest point it could take on is, you know what? I think I made a mistake in the arithmetic. Let me see if I did a mistake somewhere. Yeah, I see it now. It's minus 1/4. Sorry about that. And I do apologize for that. Let me get my eraser out. Okay, sorry about that. What's the range going to be from -1/4 inclusive off to infinity? All right, what was our question now? All that work, what was our question? Find the x and y intercepts. Did I do that? I did. They didn't ask me to graph it. Did a great job. Why do we graph? Well, practice. Let's go to number 5. Number 5 looks like trouble. All right. So it says, the height h in meters of an object thrown upward above the ground can be modeled as a function of time, t in seconds. So I want to outline what they've kind of said, and you want to concentrate on this as well. They said h is in meters, right, above the ground, by the way, and t is in seconds. And an object is being thrown upward. It says it's reasonable, as we know, what goes up comes down. Suppose one of the models is, they give me the model over here. Looks crazy, doesn't it? So h is in meters, t is in seconds. It says here h is set to be a function of time. That's why we write down as h is a function of time. Clearly, this is a parabola, and I suggest that you construct a rough graph before answering these questions. Let's see if we can do that. And as I do this over here, I point out for a lot of students, graphing is difficult. Let me just see if I have any graph paper left. Oh, I got some right over here. I'm going to pull that over here now. And let me just, and I'm gonna see if I can do it. All right, so let's write this down. H equals, well, I'm going to try to factor that. And this might seem crazy to you. I'm actually going to factor out 4.9. Because I want to graph it. So what times 4.9 will give 14.73, right? Plus 2t minus t squared. All right, let me repeat this. 4.9 times 3 is 14.7. That's 12 and 2.7, 14.7. 2 times 4.9 is 9.8. I think you're working out beautifully. Whoever wrote the problem really was kind to me. 4 times minus t squared is minus 4.9 t squared. Let's keep going. Maybe it's even nicer. Let's see what you get. 3 and 1, t and t, plus minus. Let's see if that works. I don't know. Maybe it doesn't work. 3 times 1 is 3, plus 3 minus t is 2t. Yep, works beautifully. So I think I'm moving along. I think it's really kind of simple at this point. So I'm going to say, whoops, sorry about that. I want to put down, things that are easy for me to put down. And this is going to be an ordered pair of numbers now. And I'll write them down for you. Whoops. It's not x and y, it's h and t, right? So let's see if, oh, I made a mistake. I put it in the wrong order. Apologize. All right, that happens sometimes. So let's see, let's let t be 0, right? And if t were 0, what would you get? 4.9 times 3, which is 14.7. We'll talk about the meaning of that later. The other points I want to come up with are really easy for me, and that's going to be 3 and at minus 1. And they would give me 0. I'm going to go over here. I'm going to plot those points over here. So minus 1, 0, and 3, 0. I think I can put the axis of symmetry in. And what would that be? The axis of symmetry would be dead center between -1 and 3. And that would be here, right? I know it's tough. Right, so it's dead center between the two. What I mean by that, there's 2 units here, there's 2 units over there. I want to get the vertex down now, right? So what's the vertex going to be? Well, the vertex is on the axis of symmetry. The axis, let me write this over here. The axis of symmetry is going to be x equals 1. The vertex is going to be 1, comma, well, I don't know. I got to plug that in, don't I? Let's do that. So if I'm putting 1 down, I'll write this over here. What's h if I put 1 down? Let's write this down. 3, I'm using this, plus 2, if t is 1, minus 1. Let's keep going. 4.9, 3 plus 2 is 5, 5 minus 1 is 4. Oh boy, I gotta do that arithmetic, right? So I'll say 4 times 5 is 20, right? But then I gotta take away 0.4 from it, so it's 19.6. Let me go over here. I'll write that down now. You know what? I need a little space here. I get my eraser out. And 19.6, right? I realize some students will argue this is just so much work. I don't think I'd ever get through the problem. But I get to 19.6. And what I'm going to do over here is I realize that, if I were to use this grid system over here and I were counting on it, 1, 2, 3, 4, I'm not 19. I'm going to count by a different number. So I'm going to make these things, let's make them 5s, all right? 5, 10, 15, 20. I'm going to say it's over here somewhere. Right? 5, 10, 15, 20. I'm going to write that down. This is the vertex. And what's the vertex? 1, 19, that's a comma, 0.6. All right. Do you remember the y-intercept? 14.7. Let's see if we can put that down. All right. So remember those hash marks going in the vertical direction are 5s. So that's a little bit below 15. Right over here. All right. Blow this up. I know it's tough. I'm going to draw a picture through that. And by the way, I'm not even thinking about the problem, by the way. There's my parabola. Right? They said maybe drawing a parabola might be helpful. You know what? I want to go back and read it to you again. And it says, h is the height in meters of an object above the ground. Well, I want to think about this again. So it's above the ground and t is in seconds. This is not an x-axis. Right? This is not good here. It's not x. And this is not y. I'm going to write down what they are. This is h, and this is t. And I want to point out that t is time moving forward. So t has to be greater than or equal to 0. So I'm going to draw my picture in that I think this really looks like this. The object's here. It's being thrown up. It reaches some maximal point, and then it comes back down. And here is where it hits the earth. Or the ground. So this over here represents the ground now. And why is that? H is 0 there. So I can't say this enough times. I'm here. I throw the object up. It goes up, comes back down, hits the ground here. All right, let's keep going back, see if we read the question. I know it's difficult. Somebody said the graphing takes me too long to get through. That's possible, but we want to be able to read, understand what we've read. Let's go back. I did my little picture. It says factor it. I've already done that, didn't I? It's right here. I'm going to circle that, check it. Did I get it right? I don't know. Ooh, I made a mistake over here. I'm sorry. And they pulled out a minus 4.9. So I'm going to rewrite this. Actually, I'm not going to say I made a mistake. What I'm going to say is they wrote this a little differently. They factor out minus 4.9. Let me write that down for you. And what would you get there? You get t squared minus 2t minus 3. H is minus 4.9 t 3 1 minus plus. All right. I want to claim this is also a good answer, but they did factor out the minus 4.9. I just noticed it over here. So factor h of t. And I noticed there's a mistake in my notes over here. I'm going to cross it out now. I'll correct it later. So I'll write this over here. H of t. You could write it as 4.9. I'll correct the notes later, by the way. 3 minus t and 1 plus t. Or you could write it as minus 4.9 t plus 1 and t minus 3. All right, I have to correct the key, by the way. So this is done. Next one shows how it hits the ground at 3 seconds. That's pretty easy to do. All you got to do is show that h of 3 is equal to 0. I'm hoping that's really easy to do. What do? Plug it into any one of the factored forms, and of course it's going to give you 0. We give you a 0 factor there or a 0 factor there. So that's true. What's the maximum height of the object? That's where the graphs can come in helpful. Let's talk about that. And I'll go back to my graph over here. Whoops. What's the maximum height? 19. Whoops, sorry about that. Is 19.6. Now 19.6 what? 19.6 meters. And that's it. All right, so we're done. And I'll correct the key, but we're done. Thank you for listening. You got to do something with the problems now, though. Thanks for listening.